Hello, folks. All right. Well, in this session, I'm going to talk a little bit about sort of a general common software lifecycle, right? The steps that we wind up going through from the moment somebody gets an idea for a software improvement or a software product to the moment where it's finally obsolete and no longer in use. So what I'm going to do is run through just one basic common model. There are a lot of different typical life cycle models that are in use. This is one of this is more or less a waterfall model, but we'll address that more later. Um, Once I go through the basics, then I want to spend a few minutes talking about the ones that we're going to particularly focus on in this course and sort of identify which ones we'll leave for future courses. So the idea is, again, we want to run through sort of the general sequence of steps that a software product goes through. So somewhere back in the beginning, somebody has to get the idea for this product or recognize that we need to improve some existing product. And they're going to come up with a collection, or we're going to have to establish a collection of requirements. We need to figure out exactly what it is the user needs from the product. What do they want? What really is the problem we're trying to solve? And what can we say about the product? What can we specify about the product where if the product does this, and this, then it will meet the user requirements. They'll be happy with it, right? That's especially important when you've got people who are paying for the product, right? You have to make sure that you know what you need to create up front, they know what they want up front, and that you can go ahead and actually build it. So then typically there'll be a planning phase after we've figured out exactly what it is we're going to build, right? A planning phase where we figure out when we're going to do different things, who we need to hire, what resources we need, what training needs to take place, all sorts of kind of planning and cost management and risk management ideas. But again, we'll, for the most part, focus on those things in later courses. For our purposes, we're really interested in these next few phases. These are the ones that we're going to focus on in this course, right? The design stage, where we sit down, we look at the requirements that we've got, and we try and look at different possible solution approaches we could build on. And we try and evaluate the strengths and weaknesses of each and pick one of these designs to move forward with. So we'll look at a design phase. And then, of course, the implementation phase you're used to from previous programming courses where we sit down and actually write the code, right, and debug it and get it working. And the idea is hopefully the design is correct to match the requirements. The implementation is correct to match the design. Then I'll go through and test the beast. And when we're testing, we want to make sure that the product that has been produced actually matches those original requirements, right? It meets all the requirements that we were given. So usually you can go through and from the requirements build up a set of test cases that will determine yes or no, is this adequate for what the client wanted. Now, once you've actually got this thing approved, you need to deploy it, right? Actually get it to the end user so that it's out there and workable, right? So what has to go through to distribute it, install it, get it set up and configured, right? Those sorts of steps. And then the long-term maintenance. It's rare for a software product to be perfect right out of the gate, so there are going to be fixes. There's going to be enhancements that we might need to release over time and changes. You know, if the other software that your product interacts with gets changed, so you know maybe the operating system it's running on gets changed, and somehow that forces us to make a tweak for our product to keep it running. Right? You've got long-term maintenance and adjustment that needs to take place until eventually this thing is put out to pasture. So again, for our focus, we're focusing on those middle three steps: the design, the implementation, and the testing. Right? For the most part, the instructor is giving you fairly detailed requirements on what they want, you know, because typically there are specific learning goals that we're trying to achieve with each lab, each assignment, each project. And so it is pretty typical for the instructor to go out and say, okay, well, this is what I want from you. So you don't usually have much to do in the way of requirements gathering. And then there's not usually a terribly huge amount of planning either, right? Often these are in fairly short chunks where you've got, a week or 2 weeks to do something. So there really isn't much in the way of planning taking place here. I mean, you've got to juggle your own time management, but that's pretty much about it. So again, these steps are largely dictated by the instructor. Typically, the products that we're producing are kind of single end user on our current system, so there's generally no real deployment to worry about, and for the most part, we're not focusing on long-term maintenance of these things either. So again, those things we'll leave for future courses, 265, the software engineering course, and 375, the systems analysis course. So we'll focus on those middle three: design, implementation, and test. All right. So again, this is pretty much saying, I think, just exactly what I just said. Right? Usually we've got a whole bunch of things that are dictated by the instructor, maybe even some of the design details, right? There might be something in particular that the instructor wants you to practice, and so they say, okay, you've got to implement, using this algorithm or using this data structure or even using these particular function interfaces. So again, we'll focus on sort of the steps post that. What have we got the freedom to decide? So in terms of the design, again, we're not thinking about code yet. We're thinking about the general structure of our solution. So we're going to take the problem and divide it into key subproblems, key data structures, think about which core algorithms we need to use for key operations. So we're deciding the high-level portions of the solution before we ever need to worry about beginning to write code. So again, that first step might be decomposition of our problem or our task into subproblems, into subtasks. So we might go through and define, if we've got this overall system that we need to create, we might divide it up into key subsystems. You've got some huge chunk of control software that you're producing for an organization. You might divide it up into a payroll subsystem and an inventory subsystem and factory management subsystem. Who knows? Sorry. So you're going through and dividing things up into subsystems. You might divide those subsystems up into different modules that are responsible for different portions of the task. So you're going through, and in the design phase, you're deciding what that logical decomposition is. And for each of these different components that you're breaking it into, for each subsystem, for each module, you're sitting down and deciding, okay, what exactly is this module providing, or is this subsystem providing? What operations is it providing? What data structures or data types is it responsible for providing and managing? What can be called and used by other systems? So we're trying to identify, again, the roles and responsibilities of each of these different portions of our overall system. Now, we also need to sit down and think about, okay, specifically for the kinds of information we're trying to manage, for the data that we're working with, how should that be stored? Are we thinking linked lists? Are we thinking trees, stacks, queues, lookup tables? What kind of data structures might we need to use, might we want to use? And again, for the most part, there's lots of different possible ways we could do something, and we're looking at the pros and cons and trying to decide, okay, which ones are the most appropriate for the problem that I've got and the design I want to go with. And so this is again, the kind of thing we're trying to break down. And we're not worried about code yet. We're just thinking about overall what's the approach that we want to use. And for each of the core operations that our system needs to perform, or our module or our subsystem needs to provide, we'll think about, well, what are the core algorithms that I want to use in this? What's the approach that I'm going to use to solve this? Not worried about code at this point, just thinking about, well, I'm going to go with, I've got to sort some of this data, so I'm going to use a bubble sort or an insertion sort or a selection sort or whatever it might be. I've got to do some kind of a search. Is it going to be a linear search or a binary search? So we might be making key decisions and thinking about, the efficiency trade-offs, the maintenance trade-offs, and coming up with ideas on which approaches we're going to use and why. And we're going to get that all documented out before we ever even think about writing a line of code. So again, for the design, once we've sat down and thought out what we're going to do and why, what our decomposition is going to look like, what our data structures are going to look like, we want to get that all documented. Right? This is particularly true in larger projects and especially true in projects that involve more than one person, because you've got a whole bunch of information you're trying to maintain, and if you just kind of have it in your head or sort of back of an envelope idea, it's very easy to forget details over time. If there's multiple people involved, it's easy for different people to have different ideas about what we said or what we decided, unless it's actually written down really clearly. So usually there'll be a design document produced that's very much like a kind of a requirements document where we sit down and write out everything that the user wants. But again, focused on the design level, focused on this decomposition, focused on the roles and responsibilities of each component. We're going through and trying to detail exactly what pieces go in which portions of our design. And we need to go through this and make sure that everybody has the same idea of what we're writing, making sure that what we've written down actually matches what we all agreed on. And this is one of those points where you often find out that you had differing ideas even when you were going through talking about the design. For a really big project, this can take a huge amount of time, right? If you've got a lot of people involved, there can be a lot of steps and a lot of discussion before you come to designs that you all agree on and that you can all work on and get it documented in a way that you all agree on. Now, these are rarely perfect the first time around. Usually these go through a whole bunch of iterations, just like when you're writing code, right? Anything complex that you're producing, you usually take a first stab at it and then refine it and refine it and refine it. And typically, even once we get what we think is a good design and a good design document, even then, once we get into actually building it, we're going to find out that there's places where we've put in contradictory requirements, or there's going to be places where we've put in contradictory information in the design, places where we've simply made mistakes in the design, places where there's something that we haven't thought of in the designs, places that there's something that we haven't thought of way back in the requirements. So these are rarely perfect, and they do need to be updated over time as we work our way through the project. Now, for this course, again, we're typically dealing with smaller problems in smaller chunks of time. So I'm not going to go through and get you to actually produce design documentation for this, but I do want people to be thinking about the design decisions that they're making. And I would like the comments to reflect, I've chosen to use this algorithm here because, or I've chosen to use this data structure here because. So just comments reflecting any key design decisions that you make. Now, again, there's going to be a lot of times where I specify that you have to use, data structure X or algorithm Y. So there's going to be a lot of times where you don't have any choice in it. But where you do have the freedom to make design choices, I would like you to make them consciously, right? To think about which way you're going to do something and why, and have a short note someplace that just reflects that. Alrighty. Now, sooner or later, we've got our design finished and we can start trying to actually build the beast. So now we want to start writing our actual code. We're thinking now about how we decompose our code into multiple files. This is especially true if we've got some really large program. We don't want just one massive file that's got everything in it. If we've got lots of people working on things, then we'd like to have things broken up so that different people can be working on different portions at different times. If we want to be able to reuse some portions of this in other projects, then we want the code for those portions to be sort of separated from the code that's specifically for this project. Right? So there's going to be all sorts of times when we want to divide things into different files. And so we have to decide on a decomposition there when we're actually building this. What goes into which file? And of course, we have to go through and actually implement all of the data types, all of the operations, all of the functions that we came up with, everything that we specified earlier, we have to now actually build. And again, if we detect flaws in our design or even flaws in our requirements, we have to go back and fix those and update our design and change our implementation accordingly. And eventually, once we get around to testing the product, once we've completed it, we are, of course, going to need to come back and revise our implementation. Now, sooner or later, we've actually finished writing our code, so we can get on to testing it, right? Seeing if the product that we produced matched what the user wanted in the first place. So we will typically come up with a set of test cases, things that check if a product matches the requirements. So this means going back to the requirements, and for each of the different requirements that the user came up with or that the client came up with, we're going through and saying, okay, can I come up with a scenario with a set of actual input data to test if the product does what we wanted? So you're going through, and for each of these test cases, you're thinking about, okay, well, why am I creating this particular test case? What is this test case checking that none of our other test cases have checked? What exact input is going in? What is the user typing in? What data has to be in files if it's reading stuff from files? And an exact specification of what the program should output and what it should produce. So the actual values it should spit out, the actual files it should create, the actual output it should display. And not just a description of it, but the actual data it should display. So our test cases are giving us an exact idea of precisely what's going in for this specific test case and precisely what's supposed to be coming out if it works. And then the idea is we create a whole bunch of these test cases, we can go through, run our program on all of them, and see if it meets all of the user requirements. Now, in fact, it's possible to make mistakes in your test cases, just like it's possible to make mistakes in design or implementation. And usually there's a debugging stage in your creation of test cases as well, where you go through and you run your program on one of these test cases and it fails, it produces output that's different than what the test case said it should. Well, then you have to go through and figure out whether the program has a bug in it or whether there's a mistake in the test case. So there is this evolutionary process where you're trying to develop the perfect test cases or perfect set of test cases as well. Now, if you've got a whole bunch of test cases based on your requirements, running all of them on your program every time you modify it to make sure that it passes everything and you haven't broken anything. This takes a lot of time if you're doing it manually, if the user's actually typing in all of the data manually as the program runs. So usually what we'll do is take the information that the user would usually type in as the program runs, store it in a bunch of files, and write a bunch of other scripts or small programs that take all of those test cases and run your program against them and see if they produce the correct output. So usually the idea is that we automate this testing as much as possible. So you can more or less at the press of a button run all of your test cases on the current version of the program. But we'll talk about that a little bit more as we get deeper into things. And again, when we're going through creating all these test cases, we've got all of the normal use that we want to check, right? If the user is entering different data values that are valid, we want to make sure that the program produces the correct output for that valid test case. But we also want to make sure that the program correctly handles any error checking that it's supposed to handle. So what invalid input might the user provide and what should the program do in those cases, right? Test cases to deal with this. And typically, as we're going through the requirements, pretty much every sentence in those requirements should be giving us ideas for more test cases. So just as one really trivial example, suppose at one point in the requirements it says something like, okay, well, for this input value, the program should handle values in the range 0 to 59. Maybe it says there should be error checking for values that are out of range, that kind of an idea. Then immediately we should start thinking about, okay, well, if it's supposed to be 0 to 59, then I better have a test case that checks that 0, and I better have a test case that checks that 59 to make sure that the program's got the boundaries right. And I should also check for things that are just outside the bounds. Try a -1, try a 60 to make sure that the program catches things that are just barely out of the correct range. Maybe one or more test cases that are somewhere inside that range, somewhere in the 1 to 58. But again, as soon as you see this phrase or portion of a sentence or sentence in a set of requirements, I'm immediately thinking, that means I need a test case for this, and it means I need a test case for that, and I need a test case for this other thing. And so going through the requirements is one of the key skills we need to develop, is to be able to go through the requirements and think about what test cases would be relevant for this particular set of requirements. All right, so that is the kind of quick and dirty general life cycle of a software product. And that's sort of the background assumption that we're going to be using for the things that we're working on this semester. Alrighty, I will leave it there for now.